Good morning. Human scale. What is it and why is it important to designers? It's important for designers because they need to have a good understanding of the size and proportions of a human when they're making products. There's two different ways that they do this. They use both the scale of the human to make sure that their products fit to the exact size, and also the shape, so they've got a good understanding of how to shape their products so that the human can interact with them well. There's a few examples on here of ergonomes. Ergonomes are very, very small, scaled models that enable a designer to work with their ideas to work out whether they are actually going to fit the humans they're designing for. You can get 2D ergonomes that are made of cardboard or plastic, and they're usually put together so that they're jointed, and the idea of them is that you can draw around them so that you can work out whether your product fits to an exact scale. They're jointed so that they bend and form and mould exactly like a human would. So if you were designing a chair, you would need to be able to put your ergonome in a sitting position to test your design. There's also wooden ergonomes. These come in a variety of scales, from a very, very small 24-inch scale up to a much larger version. Again, these are jointed to make sure that they bend and twist exactly like a human would, so that they can be moulded into a specific shape and drawn or sketched. This is a hand ergonome, and you can see here that this has got the joints within the wood to enable it to bend and twist exactly like a hand would. And this is used again for artists and designers to study and to check when they want to see exactly how a hand would work. We can also get full-sized ergonomes, and of course we don't usually call these ergonomes, we call these crash test dummies. And they're used mostly in the motor industry. They're used to test the design and the safety of chairs, to make sure that the chair is not only comfortable to sit in, but also that that sitting position is the most safest sitting position that a human could be in. Some of the ergonomes not only are full size and weighted so that they are the same as a human, they are also electronically fitted so that they can test further things. They can look for pressure and forces within the crash and give back feedback via electronic devices. When we look at human scale, the key thing we're looking for is something called Anthropometrics, and this is quite an old form of study. Anthropometrics is looking at just human size, and you can see it's derived from two parts. Anthro, meaning mankind, and metrics that come from the word to do with measurements. So we're using the human scale to get an idea of how to measure things. And of course we did used to use the human body to actually measure things. So we used to use our feet to measure pieces of wood and various objects, and we would use our hands to measure horses. Of course, we don't tend to use this sort of measurements much anymore, but we still need to have human scale. Anthropometrics then is a collection of data of a human that is used to enable the designer to make sure that his designs fit. So for example, if we were designing a tool, we would need to have a really good understanding of the width of a human hand and the length of a human hand, so we can make sure that the tool fits. There is lots and lots of data that is collected. This is some of them you can see on this diagram here. Once this data is collected, it is then averaged out. The very, very top percent is discounted, and the bottom 10% is also discounted. And the reason for that is that they need to get a really good idea of an average collection of data. The two extremes, the top and the bottom percentile, are used for designers that want to look at those particular anomalies. So for somebody that wants to design things for very, very small people, perhaps they're designing a particular tool that they need to look at those measurements, they would use that data. But on the whole, most tools and most products use the average set of data that is collected. And as you can see, with children, they collect data on a yearly basis, so up to the age of 18, they would classify children within their own age group. Here's a range of hand measurements. So if we were looking for some details of some hands to collect the data so that we can design a product, you can see here a range of some of that very, very detailed data that needs to be collected for designers. One thing we would really need to know is this. It's called the grip. So the diameter across here, from here to here, is also collected to hold the space within the hand. And the reason they would need this data is, of course, if you're designing something like a handle, you'd need to know the absolute diameter that needed to be, the maximum that you could get away with, or something like a handlebar, you'd also need that data. Something else we need to think about is not just the scale, but also the shape. This is called ergonomics. So as well as understanding the size of a human hand, we need to have an understanding of the shape within here. And of course, it's not just hands, it's the whole of the human body. So on the diagram here, the chair has been included some ergonomic features to make sure that this product is ergonomically fitted to this human being. Things that make the chair more comfortable, more user-friendly. So even the wheels included on the bottom are an ergonomic feature. The padding on the back of the chair is an ergonomic feature. The wrist support that gives you some support underneath the arm is also an ergonomic feature of this chair. Ergonomes are really good to help us do this, and as you can see, here's some examples of how ergonomes are used to test products. We can also use virtual ergonomes. So in the world of software, we have virtual figures that are used to enable us to test products in lots of different ways. These again are scaled models of a human being. They're also designed to flex and move and be exactly like a human so that they can be used to test various products. You can also get ergonomes, virtual ergonomes, that have interiors. So for example, a virtual human body would be used in the world of science and forensics. Crash test dummies, as we said, are full-scale humans that are used in the world of the motor industry. And as you can see here on the bottom left, we have a whole family of ergonomes. We don't just get full-scale male versions, we get right down to little tiny baby versions. These are because we need to test all the seats in the car, including car seats for babies and the rear seats. Very often the drivers and the passengers are placed within the car and they are put at a sitting driving position. So you can see here, not only is the crash test dummy fastened in with a seatbelt, he's also got his hands taped to the wheel and his foot taped on the accelerator pedal. This would give a really good measurement then of what would happen in a crash simulation. All the sensors within the driver's dummy is also giving us some readings back to tell us how much force is applied when this dummy goes through a crash by the car seat that goes across his chest, or the force that is impacted on him when he hits the steering wheel.